In every heartbeat, the universe hums softly, waiting for you to listen. This is Dreamy Science, where curiosity dreams in the language of stars. The surface is always louder than it seems. Waves shimmer like scattered light, gulls wheel above the horizon, and somewhere in the distance an engine hums. But just beneath that brightness, everything changes. Sound fades, the water thickens, the world begins to slow. Tonight we follow that silence downward. The ocean does not have a single beginning. It begins everywhere at once, in rainfall and rivers, in the breath of wind that folds the waves, in the gravity that pulls everything home. To descend is not to leave Earth, but to enter it more fully. With each meter down, sunlight loosens its grip, color drains from blue to gray, and warmth becomes memory. Yet the deeper we go, the more alive the planet feels. At first, there are still traces of day. Silver fish darting through shifting light, ribbons of plankton glimmering like dust in a sunbeam. Then the glow fades. By 200 meters, the last rays of the sun are gone. Ahead of us stretches a world without dawn, without shadow, without horizon, only depth. The ocean is vast enough to hold every mountain range on Earth and still have room for silence. Beneath the waves lies the longest mountain chain on the planet, the mid-ocean ridge, more than 60,000 kilometers long, looping around the globe like a scar of creation. Here the crust of the Earth splits apart and molten rock wells up from below, cooling into newborn sea floor. Each eruption adds a thin layer of story to the planet's skin. Some peaks rise high enough to break the surface, forming islands like Iceland. Most remain hidden forever, wrapped in pressure and night. The numbers are easy to recite. Thousands of meters deep, millions of square kilometers wide. But numbers can't capture the feeling of it. To move downward through the ocean is to leave behind the familiar tempo of life and enter one that belongs entirely to gravity. Down here, pressure doubles every 10 meters, 100 meters, 10 times the weight of the sky, 1,000 meters, 100 skies pressing in. At the bottom of the trenches, the force is enough to crush steel, and yet life continues, soft, translucent, almost unbothered. Pressure is not an enemy here. It is the architecture of existence. Every creature that lives below the light has learned to yield to it, to trade rigidity for grace, to let the water shape the body rather than resist it. Some fish have bones as thin as parchment. Others have no bones at all, their shapes held together by jelly and faith. Where we would collapse, they endure by giving way. As we drift deeper, the temperature falls. The sea absorbs heat slowly, like an old memory refusing to fade. But eventually, even memory surrenders. The water around us settles near freezing, a perfect stillness. Each movement feels sacred, deliberate, slow. This is the mesopelagic zone, the twilight layer, stretching from 200 to 1,000 meters. Scientists call it the twilight zone because a faint ghost of sunlight still filters down, enough to sketch outlines but not enough to live by. It is home to strange silhouettes, lanternfish that glitter like stars, hatchetfish whose sides mirror the dim glow above to disappear from view, small squid that pulse with internal light. Every creature here has learned a language of brightness and absence, a Morse code of survival in a half-lit world. The light we see now isn't from the sun. It comes from life Bioluminescence, a word that sounds like music. It means light made by living things, a soft glow born of chemistry and need. Deep-sea creatures carry it inside them, not as decoration but as communication. Some use it to lure prey, others to warn, others simply to say, "I am here in the dark." A jellyfish pulses like a beating heart. A shrimp releases a cloud of blue sparks to vanish behind. An anglerfish dangles a single orb before its mouth, waiting motionless until curiosity delivers dinner. In the ocean's eternal night, light becomes a kind of prayer. What we call darkness is not absence, but potential. Down here, evolution has rehearsed every possible answer to survival. The deeper we go, the stranger and more elegant those answers become. Imagine an ecosystem built not on sunlight but on the slow drift of what dies above. Scientists call it marine snow, a gentle, endless fall of microscopic debris, bits of plankton, fragments of shells, flakes of organic dust. Each particle sinks for weeks before it finds the bottom. To most of us, that sounds like decay. To the deep, it is nourishment. Sea cucumbers graze in slow motion. Tiny worms weave through sediment. Crabs patrol like ghosts. Even death here becomes part of the rhythm, a quiet recycling that has gone on for millions of years. If you keep sinking, gravity becomes almost philosophical. Every few hundred meters something changes. The water grows heavier, the light colder, the silence more exact. The creatures around you grow softer, slower, more translucent, as if transparency itself were an adaptation. Their lives unfold on timescales we barely recognize. Some deep-sea clams live for more than 2 centuries. Certain corals, growing millimeter by millimeter, have existed since before the first human city was built. Here, time doesn't march, it drifts. Pressure, cold, darkness, each of them at the surface would seem hostile, but together they form a balance, a quiet stability that the surface world has forgotten. The deep ocean is the planet's slow heart. It doesn't rush, it endures. At 3,000 meters, we reach what scientists call the bathypelagic zone, the midnight layer. No light from above survives here, not even a hint. The temperature holds just above freezing, and the weight of the ocean above is hundreds of times greater than what we feel at sea level. And yet, there are eyes staring back. The vampire squid lives here, drifting like a thought. Despite its name, it feeds not on blood, but on detritus, particles of marine snow caught gently in filamented arms. Its body glows faintly red, its eyes blue, its movements so soft they seem imagined. When threatened, it releases a cloud of bioluminescent mucus that floats like sparks in a dark room. It does not fight, it distracts, it trusts the darkness to protect it. Nearby, the gulper eel drifts, all tail and mouth, a creature of improbable geometry. It doesn't chase prey, it waits. Its jaw unfolds like a net, wide enough to swallow something nearly its own size. Hunger down here is an occasional event. To survive is to make the most of rarity. The deeper we go, the more the ocean feels less like water and more like thought, an enormous consciousness where life is slow, deliberate, introspective. This isn't just the bottom of the sea, it's the underside of existence, a mirror of everything we hurry past above. Down here, there are no schedules, no noise, no light to distract, only persistence. Every layer of the ocean tells a version of the same story, pressure refines, darkness clarifies, silence teaches. At the surface, we chase light. In the deep, life learns to make its own. Even now, with satellites orbiting Mars and telescopes reaching galaxies, we have mapped less than a quarter of our own ocean floor. We know the craters of the moon better than the trenches of our own planet. Beneath the blue we call familiar lies an entire world that is not just unexplored, it is barely imagined. Whole mountain ranges are still unnamed. Entire ecosystems rise and fall in perfect secrecy. The deep does not hide from us, we simply haven't learned how to see it. To map the sea, we send sound instead of light. Sonar pulses downward, bouncing off ridges and plains, translating echoes into shape. But even these maps are blurry, built from inference and patience. A single research vessel might take months to chart a region the size of a city. The result, the seafloor remains a mosaic of mysteries, fragments of knowledge floating in a sea of unknowns. And yet that ignorance is oddly comforting. The ocean, after all, reminds us that not everything must be known to be meaningful. Some things exist to teach us humility. When the first explorers descended in submersibles, they spoke of the deep as another planet, silent, vast, eerily calm. In 1960, Jacques Picard and Don Walsh reached the Challenger Deep, nearly 11 kilometers down. They described clouds of sediment rising like snow, a darkness so complete it felt physical, and to their astonishment, small life moving near the bottom. Even there, under 8 tons of pressure per square inch, the world was not empty. It was alive. If there's a lesson in the descent, it's this. Life does not wait for comfort. It builds in darkness. It thrives where the rules should say it cannot. Every meter down reveals a new expression of resilience. Every shadow hides a kind of beauty. The ocean doesn't separate us from the earth. It completes it. The deep isn't somewhere else. It's what lies beneath everything, even us. To understand it is to remember how small and how connected we are. So let yourself sink a little further. Let the sound of the surface disappear. Let the pressure settle around you like a blanket, not a threat. This is where light ends, but not where wonder does. Down here, time has a different rhythm. The heart slows, thoughts drift, and in that drifting you begin to feel what the planet feels. A vast patience, a quiet persistence, a reminder that depth is not distance, it's intimacy. The descent is not about falling, it's about arriving. The deeper we go, the more the earth begins to breathe. Here, in the black heart of the ocean, the planet exhales through cracks in its crust. Superheated water pours out of fissures, dark and shimmering, heavy with minerals drawn from the mantle. These are the hydrothermal vents, the black smokers and white smokers that dot the mid-ocean ridges like underwater volcanoes. Temperatures here can reach more than 400 degrees Celsius, hot enough to melt lead, yet life gathers around them in brilliant crowds. What burns at the edges of fire would destroy most known organisms, but the deep has other rules. Around the vents, life builds itself from chemistry instead of light. At the surface, all living things depend on photosynthesis, the alchemy of sunlight, water, and air. But here, where no light reaches, another engine runs: chemosynthesis. Bacteria use hydrogen sulfide, methane, and metals from the vent fluids to forge energy. They turn poison into nourishment, transforming the vent fields into ecosystems rich enough to rival rainforests. Giant tube worms rise like white towers, their crimson plumes waving in the superheated flow. They have no mouths, no stomachs, only a hollow body filled with symbiotic bacteria that digest chemicals on their behalf. Their blood is laced with special proteins that carry oxygen in water too toxic for most life. In exchange, the worms provide shelter. Together, worm and microbe form a quiet covenant. Life through partnership. Nearby, clams and mussels the size of dinner plates nestle in clusters, feeding on the same chemistry. Shrimp, glowing red under infrared light, crowd the vent chimneys by the thousands, scraping bacteria from rock with tiny claws. In their pale faces you can see the ingenuity of evolution, the way life bends itself toward any source of energy it can find. Seen through the eye of a submersible, a vent field feels almost alien. Black smoke rises in plumes, curling and vanishing into darkness. Minerals precipitate out of the hot water and harden into chimneys, some taller than houses. The light from the submersible's lamps catches swirls of particles that drift like ash in still air. And amid this volcanic desolation, everything glows. Faint blues, ghostly greens, the pulsing red of tube worm crowns. It looks less like Earth and more like a vision from another planet, a place where creation is happening in slow motion. For centuries we imagined life as something fragile, dependent on warmth and sunlight. The discovery of vent ecosystems changed that. It revealed that life is not tied to the sky, but to energy, wherever it hides. It suggested that on distant moons like Europa or Enceladus, where oceans lie beneath ice, similar worlds might breathe and bloom unseen. Even in its strangeness, there is order. The vent fields are brief in geological time, a few decades, perhaps a century, before shifting plates choke them off. When that happens, the life that gathered there must move on, drifting through the abyss until it finds another vent to claim. The deep teaches not permanence but adaptation. Everything here survives by learning how to leave. A few kilometers away, beyond the reach of volcanic heat, another kind of city rises, cold, quiet, ancient. These are the cold water coral reefs sprawling across continental slopes and seamounts far from any sunlight. Unlike tropical corals, they host no symbiotic algae. Instead, they feed by reaching out with delicate arms to catch particles drifting in the current. Their growth is agonizingly slow, a few millimeters a year. But over millennia they build enormous structures, towers and labyrinths of calcium carbonate that shelter fish, crustaceans and worms. Some of these reefs are older than human civilization, older than the first written word. One off the coast of Norway is thought to be 8,000 years old, a living monument to patience. The deep may move slowly, but it never stops creating. Seen under a submersible's lights, the corals appear pale, almost translucent, Their branches twist like glass filigree, catching drifting snow. Around them, fish weave in slow patterns, their scales flashing silver green. Sponges anchor themselves to the coral skeletons, filtering the water for microscopic food. Each reef is a city of stillness, its architecture shaped by both growth and decay. Every living coral builds upon the bones of its ancestors. These hidden forests are fragile, though. A single trawl net can shatter centuries of growth in minutes. Because they live beyond sight, their loss is easy to ignore. Yet their presence matters, not just for the species they host, but for the planet's carbon balance. Cold water corals store carbon in their skeletons, locking it away in the deep for millennia. Their patience is part of the Earth's breath. Between the vent fields and the coral forests lies an entire geography of wonders. Brine pools, methane seeps, cold seeps, hydrogen-rich oases where the Earth leaks slow miracles. In the Gulf of Mexico, for instance, pools of dense, salty brine collect in depressions on the seafloor. Because the brine is heavier than seawater, it forms visible lakes beneath the ocean, complete with waves, ripples, and shores. Submersibles that approach these pools describe a surreal sight. A mirror within a mirror, an underwater horizon. The edges of the pools are lined with mussels and tube worms, species adapted to the toxic chemistry of hydrogen sulfide. If a fish swims too far into the brine, it doesn't return. The density suffocates it. These lakes within the sea are both deadly and alive, reminders that nature's boundaries are porous, that one world can hide inside another. Elsewhere, methane bubbles rise from the seabed like exhalations. Some ignite into flares when they meet oxygen-rich layers. Others feed microbial colonies that convert gas into life. These are the cold seeps, cousins of hydrothermal vents, slower, quieter, but equally profound. They teach us that creation isn't always a blaze of energy. Sometimes it's a whisper. As we drift through this landscape, it becomes clear that the deep ocean is not a desert. It's a mosaic, a patchwork of oases connected by distance and patience. Each vent, reef, and seep is a heartbeat, small on its own, but together they form the slow pulse of the planet. Between these living cities stretch the abyssal plains, vast flat expanses of sediment thousands of meters deep. They look empty, but every inch hides life. Tiny worms, transparent crustaceans, bacterial mats invisible to the eye. Whale falls, the bodies of whales that have sunk to rest, become temporary ecosystems that last for decades. Sharks and hagfish arrive first, stripping the flesh. Then the Osedax worms come, drilling into bones to extract nutrients, accompanied by bacteria that feed on the released sulfides. Even decay is an act of continuity. There is something almost spiritual about that economy of waste. Nothing is wasted because nothing is separate. The whale feeds the worms feed the microbes enrich the sediment that will one day feed something else. The deep has no concept of endings, only transformations. Above these plains, gelatinous creatures drift like living thoughts. Transparent jellies, ribbons of siphonophores, tiny crustaceans that shimmer with blue-green light. Many of them are so soft that if you tried to touch them, they would collapse. Their beauty depends entirely on pressure and darkness. Bring them to the surface and they vanish. It's a fragile beauty, but no less real for its fragility. We often say that the ocean is alien, but perhaps it's the other way around. Maybe it is we who are out of place, air-breathing beings trying to understand a planet that is mostly water. After all, more than 70% of Earth's surface is ocean, and most of that is deep sea. By volume, this is the true biosphere, the main stage of life on Earth. The surface, bright and busy, is just a thin film. And yet, despite its magnitude, the deep is gentle. It moves slowly, organizes itself around endurance. In a world of extremes, it teaches moderation. In a world obsessed with speed, it shows the elegance of slowness. The corals that build cities of stone, the bacteria that eat sulfur, the worms that grow without mouths, all of them follow the same principle. Find energy where it exists, use it sparingly, build patiently. It's an ethic the surface world could learn from. Science tells us that life began in conditions much like these, near hydrothermal vents, where heat and minerals met cold seawater to create chemical gradients rich with possibility. Perhaps the deep is not just a mystery, but a memory, the echo of our own origin still burning in darkness. When we watch the tube worm forests sway in venting currents, we may be looking at the living descendants of the planet's first spark. Somewhere between the black smoke and the coral snow, we find an unexpected peace. The deep is full of extremes, but it does not feel violent. It feels patient. It does not seek balance by stillness, but by motion so slow we mistake it for silence. The vents flare and fade, the corals grow and crumble, the plains collect dust that will one day harden into rock. Everything changes, everything remains. Above, the surface world rushes and burns, but down here, creation happens in whispers. If the ocean has a lesson, it is that not all power is loud. Every evening, as the last light slides off the surface of the sea, a quiet revolution begins. It is the most massive migration on Earth, a planetary breath that no human eye can see, yet one that happens every single night. Billions of creatures rise from the twilight depths to feed near the surface, then retreat again before dawn. Tiny shrimp, jellyfish, lanternfish, and squid, entire populations traveling hundreds of meters up and down, synchronized with the turning of the planet. To them, night is not an absence of light, it is opportunity. This movement is called the Deal vertical migration, and it is as old as the ocean itself. Each night when darkness offers shelter, the deep comes alive. Plankton blooms near the surface and the feeders follow. An invisible tide of bodies ascending through the water column. With sunrise they descend again, vanishing into the dim safety of the depths. The scale is almost unimaginable. If you could see it from space, you might watch the sea itself breathing, inhaling at dusk, exhaling at dawn. The total biomass moving in a single night outweighs every migration on land combined. It is as though the ocean carries a heartbeat that pulses once every 24 hours, a rhythm of hunger and survival. Each creature participates without knowing the whole, and yet together they maintain balance, not just for themselves but for the planet. As they rise and fall, they transport carbon, nutrients and oxygen between layers of the sea. When they feed at the surface and sink again, the carbon inside them descends too, sequestered in the deep for centuries. Scientists call this the biological carbon pump, one of the quiet systems that stabilizes Earth's climate. Without it, our atmosphere would hold far more carbon, our world much more heat. So the ocean's breath is not poetic, it is practical. It cools the planet, it keeps us alive. But to those who descend with it, or simply listen, the experience is closer to magic than mechanism. In this darkness, sound reigns where light cannot. The ocean carries sound faster and farther than air. It can travel thousands of kilometers through a special layer known as the SOFAR channel, where temperature and pressure bend sound waves into a natural highway. Whales use it to speak across oceans. Submarines use it to hide and listen. Somewhere within that invisible corridor, the earth is always whispering. The deep is alive with acoustic signatures, the rhythmic clicks of sperm whales hunting in pitch black, the low-frequency moans of blue whales echoing across basins, the percussive drumming of fish striking their swim bladders to claim territory or call mates. Even the tiny snapping shrimp, no bigger than a thumb, can fill an entire bay with crackling pops, the sound of cavitation bubbles collapsing in bursts of light and heat. To our ears, the ocean might seem silent. To its inhabitants, it is a constant conversation. Scientists have named some of the ocean's mysterious sounds with human tenderness: bloop, Julia, slow down, upsweep. Each is a riddle captured by underwater microphones. Some turned out to be icebergs carving, some volcanic tremors, some remain unknown. We search for meaning in every sound, as if the planet itself were trying to speak and we just haven't learned the language. Sound, in a way, is the ocean's memory. Light disappears after a few hundred meters, but sound persists, wrapping around mountains, bouncing off valleys, bending with currents. It carries not just information, but time. A whale song recorded today might still be echoing faintly 1,000 kilometers away next week, a lingering note in the planet's symphony. When the first hydrophones were lowered into the depth during the Cold War, we expected to find quiet. Instead, we found music. The ocean hums. There is a constant low vibration, part tectonic movement, part wave energy, part biological chatter, a continuous background note around 15 to 30 hertz. Some call it the Earth's hum. It's too deep for human ears to hear unaided, but it's always there, vibrating through continents and bones alike. Every creature with a body feels it, even if it doesn't know it. To live in the sea is to be part of that orchestra. Some fish use sound to navigate, to find mates, even to coordinate migrations. The black drumfish produces calls loud enough to be heard miles away. Humpback whales compose songs that evolve year by year, passing from one population to another like folk melodies of the deep. Dolphins click and whistle in dialect so complex that some scientists believe they may use names, unique sound signatures for individuals. It's not just communication, it's recognition. The sound says, I am here and I am one of you. And perhaps, in a quiet way, that's what all life does. It sings to announce its existence, to confirm its belonging. For humans, sound is fleeting. For the ocean, it is structure. Even the shape of the seafloor influences the songs that travel through it. Canyons and ridges act like instruments, shaping echoes into patterns. The Mariana Trench, for example, is both the deepest valley and one of the most acoustically resonant places on Earth. When we listen closely, we are not eavesdropping on an alien world. We are hearing the planet breathe through its own corridors. Down here, in the mid-water darkness, creatures move in time to that pulse. Some, like the hatchetfish, angle their bodies so that their mirrored scales reflect only the faintest light from above, disappearing entirely to predators below. Others, like the lanternfish, emit precise flashes of light to communicate in code. A flicker for recognition, a sequence for courtship. Each species uses a combination of light and sound to locate others in an environment where vision is limited, but awareness is vast. It's easy to forget that evolution doesn't design beauty for us. The shimmering schools of lanternfish, the choruses of whales, the spectral glow of jellyfish, all exist because they work, not because they please. And yet in their function there is grace. The patterns of survival become art by accident, and in witnessing them, we glimpse our own reflection, creatures building meaning out of necessity. The night ocean teaches perspective. To survive here, life must move carefully, listen constantly, and waste nothing. Every movement, every flash, every sound must justify its cost. It's a lesson in restraint, in doing enough but not more. At the same time, the deep is a masterclass in resilience. Where light fails, organisms invent new ways to see. Where warmth vanishes, they create their own heat through metabolism. Where oxygen thins, they slow their hearts until survival becomes a kind of meditation. Some deep-sea fish reduce their metabolism so drastically that they can go months without eating. Others, like the Greenland shark, move so slowly and live so cold that their lifespan may reach 5 centuries. To live that long is to be almost geological, to feel time not as a sequence of days, but as the turning of ages. The ocean doesn't rush to evolve. It waits until necessity invites invention. Each adaptation, each new trick of chemistry or structure is a quiet solution to an eternal question. How can life continue, even here and always? The deep answers with creativity. Some species make their blood antifreeze, others replace hemoglobin entirely. Some invent organs that glow. Others produce eyes the size of dinner plates to catch the faintest glimmers of bioluminescence. At 11,000 meters, amphipods live in water so cold and pressurized that their cell membranes would freeze or burst anywhere else. Yet they persist, calm, almost delicate, moving through darkness as if nothing were unusual. Pressure, darkness, cold, 3 conditions that combined should mean extinction. But here, they are the recipe for endurance. And perhaps that's why the deep feels strangely human. We too adapt to unseen pressures. We too seek light when the sun is gone. We too make sound, words, music, stories to remember that we exist. When you listen to the ocean's nocturnal symphony, it's easy to imagine it as a metaphor for consciousness itself, a vast, layered field where ideas rise and fall, collide, echo and fade. The surface mind, bright and restless, forgets what moves beneath. But the deep mind, patient, quiet, rhythmic, keeps everything in motion. So when you next stand by the sea and hear the faint roar of surf, know that beneath it lies a choir too vast to imagine. Each note, from the smallest shrimp's snap to the longest whale's call, folds into the same hymn of persistence. It is not a song of triumph or despair, it is a song of continuity. The night moves, the sea speaks, and the earth listens. Somewhere between the rhythm of migration and the resonance of sound, there is a truth that science and spirit both understand. Life is not a static state, it is a pattern of movement and memory. The ocean remembers not through words, but through flow. Currents carry stories, sounds become echoes, light turns to chemistry and back again. And through it all the planet breathes. The descent that began as silence now becomes music. Every flicker of light, every pulse of sound, every rise and fall of the nightly migration, all of it is part of the same message whispered through water. To endure, move with the rhythm, not against it. To be alive, listen. If you listen long enough, the ocean begins to tell a slower story, one not of life and movement, but of the earth itself becoming and unbecoming endlessly. The seabed beneath us is not a graveyard, it is a forge. Every inch of it, even now, is alive with motion so slow it feels eternal. A planet rearranging its own bones beneath a blanket of water. At the mid-ocean ridges, the crust splits open and magma rises from below, molten and impatient. When it meets seawater, it cools instantly, forming pillow-shaped rocks that stack into new crust. This process is called seafloor spreading, and it never stops. Each year the Atlantic grows wider by a few centimeters, the same pace as our fingernails.
It's not dramatic, it's quiet. But over millions of years, that quiet accumulates into continents.
These ridges stretch for more than 60,000 kilometers, a scar encircling the planet, a ring of creation. They're the true spine of the earth, hidden beneath 4 kilometers of ocean. Hot water gushes from their cracks, feeding vent fields, seeding minerals, building landscapes no sunlight has ever seen. In some places, black smoke curls upward. In others, clear jets of superheated water shimmer like glass. The water here is laced with metals, iron, manganese, copper, even traces of gold, dissolved and reprecipitated in endless cycles. The deep breathes not through lungs but through vents, and what rises must also fall. Where one plate is born, another must die. On the far edges of oceans, at subduction zones, the crust bends downward, sliding back into the mantle. It's a process as ancient as the planet itself, the ocean floor sinking beneath continents, carrying sediments, minerals, and the remains of entire ecosystems into fire. This slow recycling fuels earthquakes and volcanoes, and it shapes the geography of the world we live on. Japan, the Andes, the Cascades, all are children of subduction. At the deepest of these boundaries lies the Mariana Trench, the planet's ultimate valley. Nearly 11 kilometers down, it is a place where pressure rises to over 1,000 times that at the surface. If you dropped Mount Everest into it, the summit would still lie beneath 2 kilometers of water. Yet even here, where light has never been and sound moves like a whisper through stone, life persists. Tiny amphipods scuttle across sediment. Bacteria feed on chemical drips from the rocks. Once, scientists even discovered a fish, delicate, ghostly white, hovering where logic says it should be crushed. The deeper you go, the less the word inanimate applies. Rock flows, water freezes, life flickers, gravity rights. Everything is participating in the same conversation, one of transformation, not stasis. Imagine the scale of it: magma rising, hardening, sinking, melting again. Mountains built and swallowed, an entire ocean's worth of crust reborn every 200 million years. If the Earth were a body, these ridges and trenches would be its lungs, inhaling and exhaling through heat and gravity. We live unknowingly on top of the planet's breath. When we send submersibles to the seafloor, they find landscapes that rival any on land. Volcanic domes the size of cities, canyons deeper than the Grand Canyon, cliffs that vanish into blackness. These are not static ruins, they're active architectures. New crust forms, sediment settles, landslides reshape valleys. Sometimes the slopes give way all at once, sending cascades of mud and rock hurtling downward, turbidity currents that carve submarine canyons and send shock waves of sediment rolling for hundreds of kilometers. On the abyssal plains, those flows slow and settle, layering the sea floor in fine ribbons of memory. Every grain of silt that lands here carries a trace of the surface world: dust from deserts, ash from volcanoes, pollen from forests, even microscopic particles from human cities. Over time, these layers compress into stone, forming a record of climate and change. When scientists extract sediment cores, they pull up cylinders of mud that function like time machines. Each centimeter might represent decades, even centuries. Under microscopes, tiny shells called foraminifera reveal the temperature of ancient oceans through their chemistry. Ash layers tell of eruptions. Dark bands mark mass extinctions when life faltered and began again. Some cores carry the unmistakable signature of the asteroid that ended the reign of dinosaurs. A thin grey line rich in iridium, a cosmic fingerprint. The ocean doesn't just hold the planet's history, it writes it continuously. Its sediments are pages written by gravity, inked with dust. bound by pressure. To read them is to understand time not as a clock, but as a landscape. And like any landscape, it changes. Currents shift, redistributing warmth and salt. Continents drift, rearranging wind and rain. Ice grows, melts, grows again. Each movement above is mirrored below. The seafloor records it all without judgment, without hurry. But even the slowest systems are not immune to us. The ocean's ledger now holds our fingerprints too. In the past century, humans have written a new chapter into the mud. Traces of plastic fibers, isotopes from nuclear testing, industrial soot, chemical residues. Even the deepest trenches contain microplastics carried by currents, consumed by amphipods, embedded into the food web of eternity. We once thought the abyss untouchable. Now we know it remembers us. The earth writes in silence, but we are loud authors. Still, the planet's memory is patient. It absorbs our noise, our heat, our restlessness, and translates it into pattern. Ocean currents shift slightly as the world warms. The great conveyor belts of water that move heat around the globe, slowing or rerouting. In the North Atlantic, where cold water once sank to power the global circulation, melting ice now dilutes the salt, weakening the descent. It's a subtle change, almost invisible, but its echoes reach everywhere, in rainfall patterns, in hurricane tracks, in the rhythm of seasons. The deep ocean is not separate from the sky. It is the sky turned inward. Even sound has become part of the record. Underwater microphones capture new choruses, the hum of ships, the thrum of seismic exploration, the distant growl of industrial activity. In some regions, human noise has increased 100-fold in the past 50 years. For whales that navigate by song, or dolphins that communicate through echo, this is not just nuisance. It's confusion, disorientation, a kind of sensory fog. In the same waters where evolution built music, we've introduced static. And yet, for all our interference, the earth endures with astonishing grace. The deep adjusts, vents, continue to breathe. Subduction carries our debris toward the mantle, where pressure and heat will one day erase it. Even our mistakes become sediment folded back into the cycle. It's humbling to realize that the planet's forgiveness is geological, vast, slow, but not infinite. We can disturb balance faster than it can heal. The ridges and trenches, the vents and plains, they'll persist for millions of years, but the lives that depend on their subtle chemistry may not. Still, there's a beauty in how the ocean responds to change. When new volcanic eruptions bury the seafloor in ash, bacteria arrive first, feeding on sulfur. When slides expose fresh rock, corals and sponges colonize it again. Even destruction becomes habitat. The planet's resilience is not resistance, it is recreation. In this way, the Earth writes the story of itself over and over. Each vent field is a chapter of birth. Each subduction zone is a chapter of return. Each sediment layer is a chapter of remembrance. And in every chapter, life finds a way to annotate, to add its own sentences of movement and color. To drift across the seafloor in a submersible is to see the handwriting of fire, basalt ridges cooled into symmetry, mineral towers gleaming in faint light, scars that stretch for kilometers like calligraphy written by pressure. No part of it feels random. Each ridge and trench, each echo in the sonar carries the rhythm of intention, not conscious but consistent. In that sense, geology is philosophy rendered in stone. It teaches that creation and destruction are not opposites, they are collaborators. That permanence is just repetition at a different pace. That every collapse is also preparation for something new. When we speak of the Earth as alive, it's not metaphor. The planet moves heat, circulates nutrients, regulates its chemistry, adapts through feedback. Everything a living organism does, only on scales beyond imagination. We are part of that metabolism. Our bodies, our breath, even our brief histories are made of recycled ocean, recycled crust, recycled starlight. The deep knows this truth intimately. Its stones were once molten. Its sediments were once sky. Its silence is not emptiness but accumulation. And so when we look down into that darkness, we are not staring into nothing. We are looking into memory itself, a memory so vast that it forgets nothing, yet forgives everything. The ocean keeps record, not to judge, but to continue. The fire beneath the seafloor will outlive us as it should, but perhaps by listening, by remembering that we are guests on a planet still forming, we can learn a quieter way to exist, one that writes less violently, one that understands that to leave a light mark is not to vanish but to belong, because the Earth is still writing, and we, whether we notice or not, are part of its pen. When you begin to rise from the deep, the first thing you notice is how slowly the light returns. At first, there is only black, the kind of darkness that feels physical, like a quiet weight pressing inward. Then somewhere far above, a soft hint of blue begins to bloom. It isn't light in the way we know it on land. It's thinner, more patient, filtered through miles of water. It feels like the memory of light rather than its presence. The ascent from the deep is not simply a climb toward the surface. It is a passage through time, backward through the Earth's own history. The abyssal plains give way to slopes where corals have built for thousands of years. Sediment thins, life grows denser, sound changes too. The constant hum of the abyss becomes punctuated by the distant songs of whales, the clicks of dolphins, the faint hiss of currents shifting between layers. The ocean begins to speak in accents we recognize. We have not truly left the deep. It has followed us upward. Even here at 2 kilometers below the surface, darkness still reigns, but within it drift some of the strangest and most beautiful forms of life ever known, creatures so delicate that they seem made of breath and water rather than flesh. Jellies pulse like slow lanterns, translucent and precise. Comb jellies ripple with sheets of color, refracting faint blue light into rainbows. Tiny plankton blink and fade like distant stars. This is the ocean's quiet constellation, the bioluminescent sea, where life writes light in patterns no human hand could imitate. Bioluminescence is not just beauty, it is communication, camouflage, and weaponry. Some creatures use it to lure prey, others to confuse predators, others still to find a mate. The deep doesn't waste effort, even its light serves a purpose, and yet, when seen together, these glowing signals form a kind of poetry, a language of survival written in blue. Scientists estimate that most of the natural light on Earth comes not from the sun, but from bioluminescent life. It's a strange thought that the planet's most abundant illumination shines unseen, far below where we live. If the ocean were transparent to space, Earth would glitter like a galaxy of living stars. Above them, whales move through the water like slow-moving planets. Sperm whales dive for miles in search of squid, holding their breath for more than an hour. Cuvier's beaked whales go deeper still, 3 kilometers down, into pressures that could crush steel. They dive not to escape, but to sing. In the quiet of the abyss where human noise can't reach, they release calls that travel for hundreds of miles, mapping the sea, connecting individuals across basins. Each song is unique, not random but structured, as if composed by instinct and inheritance. When the first humans recorded these songs, they seemed almost sacred, as if the whales were not just speaking but remembering. In their long, echoing notes lies something ancient, something that belongs to the ocean's original pulse. We do not yet know how fully they understand one another. But perhaps that's not the point. The whales don't sing to be understood. They sing because the sea listens. And as they rise again to breathe, breaking the surface in a slow burst of air, they bring the deep with them, the chemistry, the carbon, the history of miles below. Each exhale is an exchange between worlds, the deep giving its breath to the sky. It's easy to think of the ocean as distant, but in truth, we live inside its cycles. The rain we feel, the air we breathe, the food we eat, all are shaped by it. When the ocean warms, the climate shifts. When it cools, ice returns. Its currents carry heat, salt, carbon, and life across the planet like invisible veins. Even the most ancient fossil on land was once part of its body. The ocean does not separate us from the world. It is the world, and yet, for all that it gives, we have begun to take too much. Far below the surface, at depths no sunlight ever touches, machines now roam, robotic collectors, scooping up metallic nodules that have been growing for millions of years. Each nodule the size of a potato is rich in cobalt, nickel, and manganese, metals we use for phones, satellites, and batteries. The nodules formed one atom at a time, layer by layer, over geological ages. And now, in a single generation, we are preparing to harvest them. The argument seems practical. The world needs clean energy, and these metals are essential. But the deep does not regenerate like a forest. Its life moves on scales too slow for recovery. A coral that took 8,000 years to grow cannot regrow in a decade. A microbial mat that stabilizes the seabed cannot reassemble once its chemistry is disturbed. We may mine the deep, but the deep never forgets. Scientists warn that sediment plumes from mining could drift for hundreds of kilometers, smothering life in neighboring ecosystems. We cannot yet predict the full cost, because we have only just begun to understand what lives there. For every new species described, a dozen more remain unnamed. For every trench mapped, another waits in silence. The tragedy is not just what we might lose, but what we might never even meet. The ocean has endured impacts before: asteroid strikes, ice ages, volcanic winters, but none as fast as us. We've warmed its surface, acidified its chemistry, filled it with plastic, and filled its silence with engines. Even in the deepest trench on Earth, explorers have found candy wrappers, bottles, and microfibers. There is no away in nature. Everything sinks, and the deep, patient as it is, now holds our artifacts like unwanted offerings. But here's the paradox. The same technology that threatens the deep is also what lets us witness it. Our ROVs, remotely operated vehicle, send back images of alien landscapes, forests of coral and sulfuric towers glowing in artificial light. Autonomous drones roam through blackness, mapping, measuring, recording. Each new mission returns with discoveries that change what we know of life. Some reveal creatures that look like translucent ribbons, others cities of sponges taller than buildings. We build machines to see what our bodies cannot withstand, and in doing so we find ourselves reflected in the creatures we discover. Fragile, curious, always reaching for light. Even the few humans who have descended to the Challenger Deep, fewer than have walked on the moon, describe the experience not as conquest, but as humility. In that crushing darkness, there is no sense of dominance, only scale. To see life glowing faintly in such conditions is to understand how little of the world we truly inhabit. We live on the skin of a planet that is still forming, still breathing, still dreaming through water. So the question isn't whether we can explore the deep, but whether we can do so gently, whether we can learn from its patience rather than impose our urgency upon it. The ocean's lesson is not a warning, but an invitation to slow down, to listen, to remember that not everything needs to be known immediately. Some things reveal themselves only in time, when the observer has learned stillness. Because the deep is not waiting to be conquered, it is waiting to be understood. If there is hope, it lies in our capacity for wonder. In recent years, nations have begun declaring marine reserves, sanctuaries that protect coral reefs, trenches and vent systems from mining and industrial fishing. These areas are vast, some larger than countries, and yet they feel small compared to the scale of what needs protection. Still, they are a beginning. Every reef preserved, every vent left undisturbed, is a promise that the future can inherit silence, not absence. And that matters, because the deep is not just a storehouse of minerals or carbon or species. It's a library of possibility, the living record of how life adapts, endures, and finds beauty. in constraint. If we erase that record, we erase a mirror that shows us who we are. As you rise nearer to the surface, the pressure eases, light grows clearer, sharper. You begin to see outlines, fish, plankton, currents shaped by wind. The surface world returns, but it feels changed, smaller, more fragile. You realize that the ocean beneath is not an underworld, but the foundation of everything above it. The sunlight that warms your face also warms the water that once held darkness. The breath you draw now may have traveled through a whale's lungs or through the spaces between coral. The planet's circulation includes us all: air, water, life, memory. One continuous exchange. And maybe that's the point. The deep is not separate from our lives. It is our life extended beyond sight. Somewhere below, creatures continue their migration toward the moonlight. Vents continue to breathe. Sediment continues to fall, writing the next line of the planet's story. Nothing has stopped. Nothing has been wasted. You think of the tubeworm forests glowing around their vents, of corals building slow cities of bone, of whales singing through dark corridors of sound. You think of the ocean as both teacher and mirror, showing us how to move, how to endure, how to belong to time instead of racing against it. And then, for a moment, you imagine the world without noise. No ships, no engines, no extraction, just water and gravity and light. A silence wide enough to hold thought itself. Maybe peace isn't found above the sea, but within it, in the patience of things that live without sunlight, in the grace of systems that endure pressure without breaking. Maybe meaning doesn't rise, maybe it sinks, deep enough to touch everything that has ever been. As your head breaks the surface, the first breath of air feels both familiar and strange. The horizon stretches endless. The waves roll in rhythm, carrying echoes of the world below. You realize that what lies beneath doesn't stay there. It rises in vapor, in sound, in memory. The ocean does not hide its secrets, it teaches them slowly. You close your eyes, the air smells of salt and wind. Somewhere far below, a whale begins to sing again. A long, unhurried note rising through water like a thread between worlds. And in that sound, the deep reminds you of what you already knew. That to sleep is to sink, that to dream is to descend, and that every time we wake, we rise carrying a little more of the ocean inside us. Sleep peacefully, wake meaningfully, and remember, even in darkness, the deep ocean shines.